Good afternoon and welcome. I have on stage with me Mr. Martin Ohmer, the Business Development Manager of FuelCell Energy Solutions, and we're going to be talking about decentralized CHP solutions. So make yourselves comfortable. If you'd like a drink, there are some ladies that will be bringing them out, so please feel free to order them, and let's get right into it. Welcome. Thank you so much for being here, Martin.
Thank you for the invitation. Well, it's after lunchtime, and also a lot of people there. That's fine. So it seems to be interesting.
Yes, and we'll make it more interesting talking about this. So,
for sure.
Could you go a little bit into why you started to focus on decentralized CHP?
Well, centralized energy production, let's say, is some kind of overhaul because of the efficiency. With a decentralized productions, you have the option to use the primary energy you're taking in out of biogas, with a much higher efficiency when in a centralized production. So we can raise the efficiency by up to 25% with a decentralized application.
You've got to hold the mic a little closer so everyone can hear you. So, about the company, I know it's a joint venture. Could you tell us a little bit more about what forms this company?
So now comes the advertisement part. Well, FuelCell Energy Solutions is a joint venture between Fraunhofer IKTS, which took over the intellectual property of MTU on-site energy, and FuelCell Energy in the US, a company which already is in the technical business since 60 years. And these two companies merged together in order to bring the large-size fuel cell over from the US and Asia. They are working there pretty well, and to develop also Europe in this part.
Okay, so you're looking to be more of a global company, and it's not just central in the EU, but you have American operations as well.
We feel worldwide, right.
Excellent. So let's talk about the product. Tell us how it works. Tell us why it's special.
Okay, well, the product, the principle of the fuel cell is quite old. It's out of 1863 or something. Well, fuel cells, let's say you can divide them in two types, the low temperature and the high temperature fuel cell. And the main part for fuel cell energy is the molten carbonate fuel cell, which have 650 degrees temperature inside for the process. And the exhaust heat has 400 degrees. That's our product. And we can produce applications for starting with 250 kilowatts up to 2.8 megawatts for a plant.
So you're looking at multi-megawatt solutions that usually get deployed for your customers?
That's the word, multi-megawatt. So it's not for residential use, it's for industrial use.
Okay, and you have 110 plants worldwide at the moment?
That's right. Actually, we have 110 plants at systems at 50 sites, basically in the US and in Asia. We have also 4 plants installed in Central Europe.
Okay, so since they're so large and they generate so much heat, as you mentioned, what is the efficiency that we're looking at for these plants?
Our molten carbonate fuel cells, our DFC, DFC is our product name, direct fuel cell, have an electrical efficiency of 47%. And they're adding on the thermal efficiency, which is depending on the heat output, for example, at 120 degrees, we still have 57% total efficiency.
Okay, and in terms of CHP electricity generation, if you look at the EU countries, can you do a little bit of comparison of how it's scaled?
Well, there is always a large from the top to the last, or from, if you see in which way ever. Let's say the front-running countries in CHP usage are Denmark and the Netherlands, with Denmark of rough 40%, Netherlands 32%. And then comes, the line is quite straight, with an average of 15%. And in France and UK, you have 5 to 6%.
So do you think that's because those countries like Denmark and Netherlands are early adopters, or they have more funding to be able to afford this? Why is there such a skew?
Well, this is historically in Europe of the energy system. So Denmark is definitely an early adopter in the wind energy and in biomass usage. As far as the Netherlands, for example, use a lot of gas. And you have the traditional structure of the power plants. But the future is changing, and so there is a lot of potential for CHP also in the other countries.
And please, if you have any questions, please raise your hand. I'll run the mic down to you, and please feel free to do so throughout the presentation. We've touched a little bit on heat and heat management. So in the winter months, you have a huge plant that is producing a significant amount of heat, which can be reabsorbed into the system, into the heating systems. What happens in the summer?
Well, what happens in the summer? So some feel hot in the summer, so why not take the energy for cooling? So this is the first option: heat in the winter, cool in the summer by absorption cooling. The other part is just to reduce the power by a certain percentage. Our fuel cells can reduce the power up to 50% of rated power, and with still having the 40% electrical efficiency left.
Okay. And in terms of the fuels that are being used, I know that you have a unique proposition in using some of the biofuels which are waste as well, which makes it an even more sustainable solution. So could you tell us a bit about the thinking behind why you chose to do it and how you've managed to do this?
Well, the idea, as far as the fuel cell is the cleanest device for CHP, we thought, well, how to reduce also the CO2 emissions, and then coming on the biogas. We can use biogas out of various sources. Food industry, ideal is out of the food industry, out of the processes, biofermenters. We can also use biogas out of wastewater and other sources. It just needs a cleaning, desulfurization of the gas, and then we can use it.
And the desulfurization does not have any significant impact on the environment either?
That's a standard process. That's no issue.
Okay, and in terms of conventional turbines and gas turbines, how do the emission rates compare to that?
Well, if you put CH4 in a process, its chemistry, CO2 is coming out, but on a reduced level. What the big advantage of the fuel cell is, there is nothing else coming out on pollutants. We have due to the fact that we do not burn the gas, the gas is in a reaction, we do not have NOx, we do not have SOx, we do not have particles. So nothing's inside, it's just coming out nitrogen, vapor, and O2. So.
Okay. Let's focus a little bit on the company and your growth. So in the last 6 years, it seems like you've grown leaps and bounds. How would you summarize the growth of this company? And then I have a leading question.
Well, leaps and bounds, if it's meant like this. Well, we started with our first multi-megawatt plant in 2009. It was also started with biogas. And I would say it was a steady growth up there. And in 2013, they installed the first 15 megawatt plant at Dominion, which is a big utility in the US. And the highlight was last year a 59 megawatt plant in South Korea.
And so the installations, I'm just trying to give people an idea of the size of the business. So the average installations you do per year, how many megawatts?
We install per year 70 megawatts worldwide.
And so let's talk a little bit about the target markets. What are the markets that you're currently targeting, and what are the markets that you would like to enter into?
Well, as CHP is flexible, we take all markets. But let's say to bring a line inside, it's the industry that uses that has thermal processes in the range of 120 degrees up to 180, 200 degrees, which is food industry, which is chemistry, pharma. If industries that need steam for their production process, this is point one. And the second one are utilities which want to produce that use their decentralized plant in a economically friendly way.
Okay. And I know that you had a very cool installation at a university recently, and they received some significant cost savings. Could you take us through a little bit of that install and the savings?
Well, this was the University of Connecticut. They installed a 2.8 megawatt plant for their heating purposes and for cooling purposes, and they could save more than $100,000 a year in their energy costs. So this is quite important. So from the economical point of view, and the system is running, they have a secure power supply, 8,760 hours a year.
So if I'm a business and I come to you and say I want a 2 megawatt system installed on my site, how easy is it to install? How long does it take from inception to delivery?
Well, how long it takes? So in Germany we have our experience with our Berlin airport, which took 3 or 5 years or more. Well, you can say it's depending on the status where you are. You can do it in 12 months if all is perfect, but the regular time is an average between 12 and 16 months.
And then what are the costs that we're looking at?
Oh, the cost. That's the difficult question.
It's
comes
always
at
a
the
difficult
end.
question.
Well, let's say it in this way. Turn it around from the dollar, turn it in years. We have in Germany a return on investment of a plant which is used within the CHP law in Germany with rough about 6 years.
Excellent. And if a client came to you and they were a hospital and they wanted to install this, they would be really concerned about the noise and the vibrations just based on the scale of your solution. How would you tackle that?
Well, there's nothing to tackle. It's just the issue. We are low noise, no combustion. So it's a low noise application, and as far as no combustion, there is also less vibrations. The main vibrations came from the inverter, and the inverter makes the noise.
Okay. And before I start off with the final question, did anyone in the audience want to ask anything? All right. So we're almost out of time, and before we finish, I'd really like to know what your future goals are for your company and where you see yourself in the next 5 years.
Well, as I mentioned before, we now are more than 100 systems, systems installed in US and in Asia, and we want to bring this by 2020. A large amount of megawatt plants here in Europe, in Central Europe, in the respective CHP application. Because what is running in other parts of the world should be also possible in Europe. It's a proven technology, it's absolutely environmental friendly, and as you've seen in the ROI, we can compete with traditional technologies.
Excellent. Well, it's been a pleasure talking to you, Mr. Ohmer. And if any of you have further questions or would like further information, there's actually two stands. One is B60. B59, sorry. And another one is right by the technical forum. So please visit the stand. And there's also a mock-up of what the fuel stack looks like. So it'd be cool to see that. Thank you so much.
It's the mock-up of the biggest MCFC stack in the world.
Excellent. Well, thank you so much for your time. And
Thanks
thank
a
you
lot.
for listening. Thank you.
Thanks.
You're welcome. And stay tuned. We're coming up with a chat about large-scale electrolysis for industry and the energy sector. We'll be back in 1 minute.